can see, notice we take the sign as well in front, is equal to -6. So the y-intercept, using the symbol that they use in your textbook, A, has the coordinates x equals 0 and y equals -0.6. We do the same thing for the slope. Now, a lot of students write, when they make mistakes here, they write b as 0 because there's nothing in front of x. But remember, the x actually has a 1 in front of it. And so now we can see that the gradient is 1. And so b equals 1, using the symbols they use. Let's look at this last one for figuring out the slope and the y-intercept. So we're going to compare to the standard form, y equals bx plus c, a, sorry. Made that mistake, so I'm so used to using it. Anyway, there's nothing for a. Well, that's true. There's actually nothing there. In other words, the y-intercept is 0. So the coordinates of the y-intercept is the origin, 0, 0. So comparing now the b, the number in front of x, this one's straightforward. The number in front of x, including the sign, is -2. So that finishes those examples. Okay, we're going to do the same thing. What is the gradient and the y-intercept of this straight line? Now, we notice that y is not yet by itself on one side of the equal sign. So we use our rules for equations, the two basic rules for equations most of the time. If I pick up a term and I change the side it's on to the equal sign, I change its sign. So I'm going to pick this up, put it over the other side, and it becomes a positive 2x over there. And so our line becomes y equals 2x. Now I can compare like before. Y equals bx plus a. There is no a, so it's actually the origin. So a is the origin, the y-intercept, and b, the gradient or slope, is equal to 2. Next one. Y isn't by itself, so I can't easily tell what the slope and the gradient is, the slope and the y-intercept is. So I need to get 3y by itself first. So I'm going to pick up this term and change the side and change the sign. Then we'll just rewrite it. So 3y equals -7, take 6x. And I've got to get rid of that 3. And when I divide or multiply, I have to do it to every term. So that's to every term, and the 3's cancel to 1, leaving just the y. I'm going to leave this as a fraction. Should always leave that. If I try to use a decimal, it's going to be an infinite repeating decimal. 3 goes into 6 twice. So now I can compare. So comparing it to y equals, this time that's the constant term, a plus bx. I can see the y-intercept is this point here, which is at 0, -7/3, and the slope is equal to -2. That's a -2 in front of the x. Here we haven't got y by itself, so it's not easy to tell what the slope and the y-intercept is. So let's get to work at changing the side and changing the sign. First, I'm going to move this 3x term, which is positive. And when it comes over here, it will become -3x. And I'm also going to move this -3. If I put it over here, it becomes +3. So I'm left with -4y equals. Now 9 plus 3 is 12. And I have this -3x as well. The last thing to do is divide everything by -4 so I can get y by itself. So I'll divide by -4, they'll cancel to 1. Divide this by -4 and divide this one by -4. So I now have y by itself. A positive divided by a negative is a negative, and 4 goes into 12 3 times. And a negative divided by a negative is a positive. So you need to take care with signs, and I'm going to leave that as a fraction. It's a simplified fraction there. And now I can compare it to the gradient intercept form or the slope intercept form and write it underneath. Or you can do this part in your head once you get good at it. And so the y-intercept we can see has the coordinates x equals 0 and y equals -3. And the gradient is the number next to the x, including its sign, which is 3/4. Now you can write this as a decimal, as long as it's an exact decimal. We don't use repeating decimals or decimals we have to round off unless it's a modeling problem. In the next lesson, we're going to look at how we go about sketching these lines.